Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh, and very good morning to everyone. Okay, we begin with Surah Fatiha. A'udzubillahi minash shaitanir rajeem. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Ar-Rahmanir Rahim. Maliki yawmiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Okay, so this one is lecture 5 and 6. Then we will have a 10-minute break. Then we have 6 and 7. Both lectures are around 40 minutes. So coming Friday, we have only attendance. There will be no lecture. Only we do our attendance. Okay, thank you. Yeah. Okay, Bismillahirrahmanirrahim. So today we have lecture 5, and it's more on usability aspects of security. Okay, so we'll see what is usability aspects. Okay, the contents for this lecture is the need for usability security, okay, interfacing with the user, security in any browser, improving how to improve usability, and then we have conclusion. Okay, it's an overview of this lecture. In our previous lectures, we learned there is a communication between Alice and Bob. Okay, so there is an entire communication. We have plain text, then we have ciphertext, whatsoever we have digital signature, then we send the data from insecure channel, then we receive the data. So between two nodes. So the concern for this lecture is whatsoever condition, we have to use any browser to initiate those communication. Okay, like if I need to have email, or I need to say, in our previous examples, we sent email using Adnan whatsoever. So we have to use browser. Any communication, I have to do transaction, I have to use browser, then go for banking website. If I have to watch movies, I have to go to browser and then download player, or we have to online. So everything must go through browser. Okay, so then and then we'll see what are the security concerns and usability issues at browser. So this lecture is more on literature review rather than any technical. So we all will act as a system designer rather than user. So we'll, okay, we see. For introduction, users often wish to protect their systems and data. Okay, we all users. Okay, so this is our concern, main concerns. So the security related features can be found in any hardwares, okay, a firewall, anywhere, okay, or some other system softwares like operating system or any application programs. Okay, so we have to click that, like Google Chrome, it's an application program. Okay, so we have to click and we have to find where exactly security related features can be found. Okay, however, the usability of the feature is sometimes a problem. Okay, like this one is Google Chrome. If we click here, we have so many different options. We click privacy and security. Okay, then we have different options. We have enhanced protection, then we have standard protection. Okay, also there is some option help improve security on web for everyone. So if you click, there is some options. Okay, so this is normally security related features can be found here. In any softwares, it depends on that particular software. So then what's the problem? If everything is there, okay, if we click here and then we can find this, okay, so the problem is understanding technical words like faster, proactive, protective protection against dangerous website, downloads, extensions, warns about your password breaches, requires browsing data to be sent to Google. Okay, this is for enhanced protection. For standard, against website download extension that we know. Okay, so the problem is with the usability as a user. If say my mom, she need to do something with this, maybe she don't understand, but she only know there's enhanced protection and there's a standard protection. Okay. So the security ought to be understandable. Okay. We should be able to determine and select the protection we require. Okay. The technology should not make unrealistic assumptions about our prior knowledge. Okay. Sometimes the designer, we as a designer, we can predict that our mom and parents, they must know all those things. Or since we are computer science graduates, so our parents, maybe they know something about computer science. So this is unrealistic assumptions. Okay, for understandable, and then we have lookatable, easy to find where exactly we can find those features. Okay, visible. Okay, also it must be visible. We ought to be able to determine whether protection is being applied and to what level. Okay, appropriate status indicators and warning will help to remind us if safeguards are not enabled. Okay, so this is usability. Convenient to use. Okay, need to maintain balance or be likely to disable features that become too much of impediment to legitimate use. Those limiting factors. Okay, like if you see, if you see one, okay, no protection, then there is an extension protection. So one, if your passport is exported in data breach, we just click it here. Okay, use secure DNS. This setting is disabled on managed browser. Why is disabled? Why we need it? Okay, manage certificates. Okay, so what is this? Google Advanced Protection Programs. What exactly this? If we use CIB Bank, click. So do we need to click this one or not? Okay, if we're using some online communication, or we have very sensitive data on communication, so do we need to click this one, or on or off, or we have to click this? So these are the concerns of this lecture. Okay, usability barriers. Okay, problems can affect end users and system administrators. Okay, so sometimes if I don't understand exactly what those technical things means and I click something, then I'm in trouble. So there's this very old survey, but now it can be worse than before, because nowadays we have very extensive technical words rather than previously. Previously we have very few technical things. Now we are using ubiquitous computing, where no homogeneous platform is required. All the platforms are heterogeneous. Previously, OS only communicate with OS. Now OS can communicate with Linux, OS. There's no hardware dependencies nowadays. Previously, we have homogeneous system. Now heterogeneity. So things are very difficult. Okay? So problems can affect end users and system. Survey of 160 system administrators included questions about technical barriers to using those tools. More than half faced problem during the installation of a security analysis tools. Okay? So this is one survey. The concern is the usability issues. Okay, interfacing with the user, just like we have seen in our Google Chrome. Okay, so that is the interfacing. So we have to be very careful from the user perspective. Either user have a knowledge or is not knowledgeable user. So we have different types of user knowledge is of two types. One is syntactic and semantic. Even me, although I am a lecturer, but still most of the time I am very device dependent. I can do very few things on my mobile devices. Okay, so that is syntactic. my father, my parents, or those old brothers, sisters, okay, they are not exposed to those technologies, are normally syntactic user. At least they can do their job. They can WhatsApp, they can, okay. Then we have semantic user. Those you people, you are completely structured. If I give you any device, you can play around by meaningful learning, stable in memory. So even most of the time, I have to reconcile with my colleagues for certain things. The same goes to my colleagues. Okay, so this is two different type of users from knowledge perspective. And then we have types of users. One is novice users, no syntactic knowledge of system, little semantic knowledge of task or computers. Anxiety inhibits learning. Okay, restrict vocabulary and functionality. Okay, even the same goes to me or my fellows. But you people, you are fully knowledge people. Okay, sometimes we have knowledgeable intermittent users, semantic knowledge of task and computers, difficulty maintaining, okay, simple, consistent, frequent user. Okay, those are those technical people. You as a designers, thorough semantic and syntactic knowledge, can use macros, shortcuts, abbreviations, anything. We have seen sometimes we give students a very interesting projects, but they can do they are more knowledgeable than, because we did our PhD. I did my PhD in 2012. Different technologies, different things. My supervisor, Professor Dr. Noshila, she did her PhD in 1995 on ATM, asynchronous transfer mode. The ATM machine is the same technology, but in 1990s, that technology obsolete. Okay, mine is more on IEEE 802.16. That is more on WiMAX, relay-based instruction, relay-based communication. So still it's there, but now previously we have homogeneous system. Now we have heterogeneous system. So almost my theories or my things are obsolete. See, so now who is the more expert is you people. Okay, you are more learner than we are experienced now. Okay, so common interface problem. Most of the time, if you people as a designer, if I hire you and then can you people come and design one browser, specifically security issues. So don't forget the user, don't forget your parents, and don't forget us. Okay, you have to make sure that at least, just like whenever we design exam paper, we have to consider the lowest grade student. We don't want to fail them. So I know maybe say Adnan is not up to that standard. So I have to see what exactly he or she can answer. So don't forget about the user. Developers often design for what they know, not what their users know. So you are expert, but don't forget the user. User feels incapable of using the product. Okay, we call this absorptive capacity. Nowadays, most of the big concern. We have technologies. In Pakistan, we have a lot of technologies, but our literacy rate is 26%, meaning that village people are 72%. So they don't want to use those technologies and they are illiterate. So if something in English or something is other language, both are same. So they really don't understand. Then if we don't understand, so we will not use the product. Too many top level features. Ensure that frequently used features are readily available. Okay. Avoid putting everything on the first screen and loading toolbar with rarely used buttons. Okay, so this is one of the guidelines. It's a common interface problem basically. Attempting to control the user. Most of the time we just there's a radio button or checkbox or something, we gray light, okay, we black it, okay. So we try to control the user that, okay, now better, sometimes you will see highly recommended. Again, we are controlling the user. Evident in application that attempts to control navigation by graying or blackening menus, items, and controls. Controlling the user is contradictory to event-driven design. User is meant to determine which event occur. Interface flexibility is empowering for the user. Okay, so golden rules for interfacing design: strive for consistency. Okay, enable frequent user to use shortcut, offer informative feedback, design dialogues to yield closure. Okay, offer simple error handling, permit easy reversal of action. Okay, reduce short-term memory load. Okay, so these are some golden rules. Okay, so this is our browser. So this is Google Chrome. If you see, we have standard protection. If I click here, what exactly I can get? Okay, so maybe warns about your password breaches, detect and warn about dangerous events when they happen. Okay, so this include these two. For this include this one. So, but I'm not sure either if I'm using CMB click, so I have to click this one or this one. Okay, this one is for IE, Internet Explorer, very seldom used. So we have medium and high. Okay, so you see security level selectable via this bar. If we do high, medium, low. Okay, so and then we have so many radio buttons. Allow previously unused active control to run without this. Allow scriptlets. Okay, these are so many technical words. Okay. If we having gone into the customer, you no longer get any indication of your level of protection. If you go for enhanced version, so we may feel like this. So, okay, too much security. If users are concerned about protection, their natural reaction may be set. Yeah, just like for me, I know I'm using CME Bank, so I need to make it high. So if we make it high, there is a problem with the browser. Okay, this is very old slides, but this can happen. Okay, then we have unfriendly dialogues. Sometimes still I can see those things. So sometimes I click yes, sometimes I click no, even I don't know. Allowing active content such as script and active X control can be useful, but active content might also harmful. So this is a dual sentence. It's useful, but maybe harmful. So this kind of things, this is under usability, and we have to make sure things are friendly. Analysis, so we can easily criticize Internet Explorer on the basis of the ease of use of its security beyond the predefined defaults. Okay, its assumptions about users' prior knowledge, the extent to which it makes the security. So these are some criticism on Internet Explorer. Okay, how to improve usability? So this is a very important slides. Okay, this is human-computer interface security guideline. Okay, so visit this literature review. Okay, visible system state and security functions. Sometimes Mozilla, you just try, go back and see, try, find where is security features, functions. Okay, sometimes for me, I have tried, so it took me time to find where exactly I can see security features. Security should be easily used. The interface should be carefully designed and required minimum effort. Okay, just radio button is enough, but should not use very more technical words. Suitable for advanced as well as first-time users. Yeah, so there's no difference because we have it. It must depend on the application rather than the users. But sometimes if I click enhance security features, or if someone click standard, so there must be some guideline of how to click those. Avoid heavy use of technical words or advanced terms. Okay, handle errors appropriately. if I click something and then say transaction occur, so which means the errors is not handled properly. Okay, so allow customization without risk to be trapped. Okay, if someone need to customize something, so allow in a very easy way. Okay, easy to set up security settings. Okay, we must know, and by reading we must know. Click this one, okay, configure this, do this, so we can do setup. Help and documentation suitable. Okay, if there's a readme options, so if something, the help must be very easy going. Most of the time if just see Google, the Mozilla, sometimes we stuck. Then we have to Google what does it mean, rather than we find help and documentation from that security features. Make the user feel protected. Okay, so this is one of the concern. Security should not reduce performance. Okay, this is how to improve. Interface improvement example. Okay, advanced tend to say this for advanced. Okay, sometimes we don't know what this advanced means. I'm looking for some, not advanced. Okay, I need to use only Google. So should I go for advanced? And then if we advance, we can find so many things: accessibility, browsing, multimedia, security, certificates, validation for this original interface. If we rework it, okay, rather than we do it advanced, just like it's security, and then security, certificates, and validations. Okay, so I think that is a little bit okay. Okay, so easy for people to do that. So this is conclusion. Security is often easier said than done. Need good default settings. This you can read back. Okay, we have another lecture. Okay, now the previous lecture is just to designing perspective. So how to design, or how to design a locatable security features, or easy to locate. So sometimes we add some technical words. We have to avoid that. We have to keep user in our mind while designing. And we should not expect user to be very expert of computer science. Just try to make a mediocre users, or those users. Now, you see, now we have browser. We know previously we have communication. So assume that we have Alice, we have Bob, and there is a communication. So now we assume that Alice, she is using some browser, but she don't know it. So from the cybersecurity perspective, we have to tell her how to use. So usability perspective. Now she is using an application program. Okay. So this program security means that we have to see how we can manage security issues in this application program. Like Skype, okay, this password protected, okay, this XLS file, PPT, Outlook, whatsoever. So we have any software is an application. System software, operating system, and some application softwares, or that is mandatory softwares, is application programs. Okay, so just visualize that I'm using some simulator online. Okay, or I'm using something downloaded version. Okay, so no need to online. I download something and now I'm using that software. So what are the security concerns with that software? Okay, so we have introduction, we have trustworthy computing, secure programs, types of flaws, non-malicious program error, okay, viruses and other malicious code, okay, targeted malicious code, okay. So It looked like difficult, but we'll see. This program is secure. What do you understand from above? Okay. How do we keep programs free from flaws? How do we protect computing resources against programs that contain flaws? Okay. So this is some of the basic research questions. Okay. For program security, our first step on how to apply security to computing. Okay. Is one of the first concern. Protecting programs is the heart of computer security. All kind like OS, database management system, network, any application, how to make sure those are secure. Okay. Issues how to keep programs free from flaws. Okay. How to protect computing resources from a program with flaws. Okay. So issues of trust not considered. How trustworthy is a program you buy, how to use it in its most secure way. Okay. So the partial answer is we have to depend on third party. Nowadays we have so many penetration testing. Even if you someone designs CMB Click website, this is an application because we can download in our mobile. It's an app. So maybe it's secure, but how we can say it's secure? Or maybe it's trustworthy or not trustworthy. So we have to see the reviews. Then we say, oh, this so many people have utilized it, so it's trustworthy. Yeah? Okay. So this is one of the basic partial answers. Okay. For the program is secure if we trust that it provides or whatever it provides. It provides confidentiality, integrity, which means it's secure. If it's not providing any of this, we can say it's not secure. So what is this? Depend on who you ask. For me, if I carefully do transaction using CMB application, I think it's okay. I think this is secure. From your perspective, if you design something and if you send for testing and it passed all the tests, then you say, oh, okay, it's secure. For management, the software houses, if they say, okay, it follow all those aspects, everything is okay, so this is secure. Okay. Development criteria for program security includes correctness of security and other requirements, correctness of implementation, and testing. So these are some criteria. Okay, sometime while designing our application, we may have some errors. Okay, small error. Okay, so those error can cause fault, cause of a deviation from intended function. So error may lead to a fault. So if there is very small error, there can be a fault in the system, which is what is the intended function, maybe a little bit deviate from that main function. The function is to withdraw money, but maybe they can give us the balance statement, whatsoever, but a little bit deviation. So failure is malfunction, means system is not working. So normally error, okay, fault seen by insider, just like you people. Failure seen by me, I'm the users. Okay. Error, fault, example, programmers indexing error leads to buffer overflow fault. Okay, buffer overflow causes system crash. Okay, so this is failure then. Two categories of fault with respect to duration: permanent faults and we have transient faults. Permanent, as the name is a permanent fault, or transient can be much more difficult to diagnose. Okay, so normally error leads towards the fault and fault leads towards the failure. Okay, what is trustworthy computing? Takes too long to break. Okay, what makes secure programs? Takes too long to break. Okay, just like CMB. If I do transaction and there is some there's insecure channel, there is a crypt analysis. Okay, so those attackers, they have done something and they try to break my keys. If it takes too long, I think it's secure. Haven't had any problem till now, it's a secure. Meet all those standards, it's a secure. Okay. So this is one of the concern why we have faulty programs in our nowadays in market. Rush to market because most of the software houses, they are industries, they are commercial organizations. Okay, so they have to rush to the market. There's a competition of finance, so they have to bring the product to the market as soon as possible. Okay, and normally in software houses, people, we get the fresh graduates and then we give them different modules. Okay, so sometimes programs too big to be secure. Okay, written in section by different groups. Okay, so it's a big program, then we have to divide into different modules. But sometimes those people, there's no team playing or there's insider issues, so we can have a faulty programs. Vendors don't care. Just like if I'm a vendor, I say never mind. We just go for the market, and if there's issues, we can later on fix it. Easier to fix than to do right. So this is one of the concern nowadays. Even if we publish any article, we just send to the editors. We know there are something not up to the standard, so we wait for the comments from the editor. So they give us the comments, we just follow those comments and get the article accepted. So this is not right. Software development moves faster than security methods. Okay, securing last year while this year being produced. Okay, so we have so many threats again. What about testing? Insufficient tool to test, can't test for every possibilities. Okay, so this is good point. Normally we test to check can you do it or not. Okay. Never test for shouldn't do that for security perspective. Okay. For patching, just like if there is a road broken, we just do a small patching, and then after 10 days patching gone. Okay, this is nowadays we can see when there's a rainy season. Immediate fault is normally fixed without looking at underlying problem. Okay, fix may have negative effect on other part of the program. Okay, so this patching is very it's not recommended. Rush to fix means little testing. Okay, even the patching itself is it's a software. So if we just patch it, and it may create some negative effect on other part of the system. Patch may break user system due to configuration or use of what was considered a fault. Okay, these are some fault. This is human errors. Previously, all this considered as a human perspective or human error. These are the intention. Viruses are again human generated. It's not the biological viruses. Okay, so this is human generated, but there is a motive behind. It's not hacking. It's a cracking system. A program that infect other programs by modifying them to include a copy of itself is a definition. Okay. Indication of viruses is sometimes computer run very slow, system runs out of the space, file size changes. This all we know now. We just right click on the taskbar and then go to task manager and then see if CPU usage 100% or your storage is 100, which means something unnecessary going on. Okay, if we can see some unknown programs are running, processes are running, which means we have viruses. Unexplained files appear on the hard drive. Okay, unexplained behavior, CD-ROM door opens and closes by its own. Programs won't execute, files won't open, characters missing from display. Okay, so these are certain indication of a viruses. How it look like, as the name indicate, behave like biological viruses. Okay, it's a very 4 to 5 line programs. Okay, are attached or attach themselves to executable file. Okay, just like in our sniffing, once we sniff, we do spoofing using email spoofing by using impersonation. we send them something. If we click that, if it's the executable file, they download something to our system. So later on, whatsoever they can send me the data. Okay, it's a very small script. Activate when the host programs is executed. Okay, maybe okay or maybe dangerous. Capable of doing anything. It's up to the motive of the attacker. Okay. Sometimes it cannot affect a system from a non-executable file. Okay. Do not cause physical damage. Can also infect those ROM, BIOS, firmware can also affect that. Typically activate on an event. Okay, when executed on date after and reboot at some random time. Okay. So it depends on the motive of the attacker. Often replicate and attempt to infect other files. Okay. It looked like a virus appended to our application program. So this is an original program. Okay. Then we have virus code. So either it can attach to this code. Okay, this code is attached to our main indexing in your system programming. Maybe later you will learn. Okay, there is indexing. So this code stay within that indexing. Okay, so this is virus code. This is this. So half part here, half part here, just like biological viruses. Okay, virus surrounding a program. Okay. Sometimes it's like that. You see, there's this color is scattered, integrated into this, and now it's a part and parcel of the program, and it's a modified version. Okay. Sometimes we have before, this is T and T here, B, and after, T goes here and T come here, overriding T. Okay. This is one of the motive. And sometime changing pointer. Okay. This point is here, but later it's changed the pointer. Okay. So this is after sniffing. Once we click the email or anything, this normally happen. Okay. Virus completely replacing program. What are the activities? Send email viruses, delete files, propagate, use resources, monitor system, modify files. Okay. So these are some of the very basic. It depends. It depends on the motive of the system. How transport is very generic. Once we click the link, we download it. That's our own concern. Someone knock the door, I just open the door. Okay. So download from the internet. Okay. We download something, and then there's option next. So we don't know there's a uncheck the box or whatsoever. We just download those malware. Email from associates. Okay. We know him, but we get the email. Sometimes we copy, sometimes from home, sometimes file sharing, sometimes. So there are so many. If we are connected to internet, we are prone to those viruses. What is the solution? The solution is your backup. There's no solution. It's just main solution is backup. If we have backup, at least we have the data. We format the disk. If we format the disk, we know that the virus is gone. No genetically of removable media. We must know the media came from where. Use only commercial softwares, not the pirated one. Okay. Review source code where possible. Okay. Test all new softwares on isolated system. No need to connect to internet. Okay. Only open attachments when you know. Sometimes I send something link and you click, gone. Make a recoverable system image. Okay. At least if something goes wrong, at least we can have a recovery. Scan anything. If we attach to the system, just scan it. Okay. Scan our system on regularly, periodically basis. Okay. Polymorphic viruses always change pattern. Okay. So this is what if we scan every time weekly. So there are certain viruses that change the pattern. Stealth viruses hidden in the hard disk. Okay. But most of the scanners, they also find hidden things. And most of the softwares, they don't find it. Scanner updates. Okay. Must find viruses, create a signature, create a fix, test, get new code distributed. something misconceptions about viruses. Virus can only Microsoft Windows. No, Linux also can. Now everything can be infected. Virus cannot modify hidden or read-only files. Okay, viruses cannot appear in data files or word files. Viruses can infect hardware. Yeah, sometimes hardware is, or it's the hardware. Viruses spread only on disk and email. It's a false. Viruses remain in memory after power off. So it's a volatile. Okay, if in RAM, then will be gone after power off. Sometimes we have parasitic behavior of viruses. Okay. Normally loaded by the user. We click it, we download it, we run it. So whilst we download, we just allow those parasite programs to enter, include additional capabilities. Sometimes have noble purpose. Okay, this is static as these are the systems. We have music sharing. 41 additional files loaded, you authorize sharing of your system, you authorize selling of your time on the system, you agree to letting them change your configuration. Because we click, we once the wizard initiate, we allow everything. Malicious code, what is the threat growing? So this is one of the concern nowadays. Okay, increase of the product. Since we have heterogeneity, ubiquitous network, then we have so many devices. Okay, so the server is only one server. Okay, so we can have different kind of OS, different kind of hardware can communicate with those. So since we have different types of hardwares or technologies or products, so that expose the system to the viruses. Experience of malware development from an infant industry to highly experienced in the past decade. Okay, so the nutshell, the conclusion for our program security is, if it's an application, so we have to make sure, no need to rush, design properly, we have to go for testing properly, okay, and then don't go for it can do it or not. See, it shouldn't do that. Okay, so there are some guidelines how to design a software, and then there's some guideline how to avoid viruses. Okay, we have to do backup. Okay, so this is some literature review slides. So I think we finished for today. Let me stop recording. Okay, so this is our lecture 7, security policies. Okay, in our previous lectures, we have learned something more on crypto system, okay, cryptography, okay, and then we have learned something about passwords, okay, and then authentication, multi-factor authentications. Those we can say it's a control. Because in our first lecture, we talk about something, there are some security requirements, and then we have security threats, and then there is some control. Okay? So to ensure control, we have encryption, decryption, we have multi-factor authentication, so many different crypto system techniques, methods, and that those are all baselines. So nowadays, if we browse through research, okay, we can see a lot of competent algorithms for each and every niche areas. Okay, so to control those security threats, we have another matters, that is policies. Without policies, we cannot control things. So we'll see what are those things. Okay, so the challenges before us: define security policies and standards. Okay, so this is two lectures. It's lecture 7 or 8. Okay, measure actual security against policies. Okay, report violation to policies, correct violations to confirm with policies. Okay, summarize policy compliance for the organization. So this is something in policies we have to do that. UNIMAs have their own policies. Okay, to ensure we have secure data, even to secure our physical assets. Okay, so first of all, we must have, if we talk about foundation of information security like your CGPA, okay, your attendance, okay, our SKTs, lecturers' KPIs, okay, annual national loads. Those are the information we need to secure. Okay, so information security policies and standard, there is one layer. Okay, and then this is upper layer where we can see the administrator, okay, and the actors. We have administrator, we have users, okay, and then we allow to whom we can allow to access to the server room, to those level 7. Somebody can have access to level 7, level 6. So this access control. Then we have information protection. So these are sub layers. Okay. And then we have one middleware. We call this managed security. Okay. So these, if we need to secure any information in any organizations, we must have all those things. Without policies, standards, this is incomplete. So there must be some access control. Okay, if there's no access control, if everybody is same, then there is. But normally, every organizations have their own hierarchy. So just like Deacon, she have their own access control. Okay, so information protection is another sub layer. Okay, so these are managing information security. So these are some layer. Okay, policies. Okay, the definition and what is the agenda of policies is to provide a framework for the management of security across the enterprise, any organizations. It's a small organization, it's a big organization, doesn't matter. So there must be some policies. If most of the universities, if we come late, there is a deduction in the salary. Okay, you see, so this is one of the policies. Okay, further, if I come late around maybe 10 minutes, 5% deduction. So this is nested policies. So we'll see. Definitions, policies is a high level statements that provide guidance to employees who must make present and future decisions. Okay. Then we have standards, requirement statements that provide specific technical specification. Okay. So that is standard. This is for everybody. Guideline, that is optional but recommended specifications. Okay. So we'll see from this diagram, we have 3 layers. One is policy, upper layer. Then we have standard, niche, and then there is some guideline. Okay, procedures, guideline, and practices. So what is policy? Access to network resources will be granted through a unique ID and password. So this is a policy that must be secure. If you have used a specific username password, so we can have this. What we call is access control. So if we have specific username password, we can access the resources just like eLeap. So that is one of the main generic policy statement. Then standard. Okay, how ID look like? How password look like in UNIMAS is a single ID. Okay, this is one of the standard. Everyone have the single ID. Okay, if it's our NC, that NC single ID. If any technical stuff, single ID. Yeah? So that is standard for everyone, as the name indicated. And then we have procedure, guideline, and practices. Password should include, okay, that is nested, and that is further specification. Okay, passwords should include one non-alpha and not found in dictionary. Okay, so that is just to avoid dictionary attacks. So these are security policies. Okay, for elements of policies, set the tone of management. Okay, we have to see what kind of policies we are looking for. If it's if information security, okay, so we have to see what we are going to manage. Establish roles and responsibilities. Okay, so once we know we are going to secure information management system in Unimas, okay, then we have to find the people. Okay, so I'm one of the internal auditor for Unimas for information security management. So they find the people and then we allocate the role and responsibilities. Okay. Define assets classification, data center. Okay, so we must know what's inside the data center, and say we have to secure ELEAP, we have to secure our students' credentials. Okay, so those are the assets. We have to classify clearly. Provide direction for decisions. Okay, so just like we have this guideline, procedure, and practices. Establish the scope of authority. Okay, if there's access control, what we have to define. What are the scope? Who can, how much we can access. Okay, provide a basis for guidelines and procedures. Okay, establish accountability. Okay, if something we fail to do that, what should happen? Okay, describe appropriate use of assets. Okay, so if it's a ELEAP, so we must know what are we have to describe explicitly. Yeah? Establish relationship to legal requirements. Okay, these are all ethical linkages. So where we have ethical, professional linkages, there must be a legal requirements. Okay. Policies should be clearly identify and define the information. Okay, information security goals and the goals of the university. Okay, so this one is policies must be clearly identify and define. Okay, so we have 10 different steps to achieve those policies. So if example, it's a Unimas. Okay, so we need to secure information security management system. Okay, we have all the data. Okay, so we collect the background information. Okay, so what are the data we have? What are the different types of data? Okay, and then we have in Unimas we have our own risk assessment department. Okay, in Chancellery level 2. Okay, so they will perform risk assessment. What kind of threats we can have on those information system. Okay, so we perform all. What are the attacks? Okay, if we are prone to denial of service attack. Okay, then we create a panel. Okay, so there must be 5 or 6 people who review the policies. Okay, so once we review the policies, so they have normally to review policies are top tier management. Okay, then we develop a security plan. Okay, so once we have review panel, we review all those security risk assessment. Then we have information security plan. Okay, then once we have a plan, then we design our policies. Okay, so we design, and then we implement policies and standard. Okay, and then we create awareness and training. Just like previously we have, now we have ELEAP. Okay, so then we create awareness and training, just like single ID. Once we design, then we implement policies, and then we have so many trainings for single ID. Okay, and then we monitor the compliance. So this is for Unimas, this is my job. Okay, so because since I'm internal auditor for our information system management system, okay, so we monitor the compliance, we evaluate the effectiveness. Okay, this is basically the job of internal or external auditors. Okay, once if there's any issues, so based on the feedback, based on we evaluate, then we have to modify the policies. Okay. So once we modify, we have to create awareness again, okay, or no need. So these are 10 steps, how to implement or how to, starting from thinking of a policies till we implement the policies. So we have 10 different steps. Okay. This was our first lecture. Okay, this one is our lecture 8. So again, very small lecture. Okay, in my last year, since, I read all the comments from the students, and then I try to make sure that I implement, I address those comments. So in my previous comments, there was a comment from one of the student that the lecture slides are not coincide with the course outline. Actually, since this is my expert area, okay, so all the lecture slides are coincide with the course outline. And I never change anything. Yes, I have to upgrade the slides. Okay, so this slide, since if we see previous your seniors slides, they have different standard. Nowadays, those standards are obsolete. So I don't want to discuss those absolute things to my students. So there's nothing change in the slides. I just upgrade the technologies. Like in our crypto system, there is applied crypto system. So for applied, for access control or authentication, if you see your senior slides, those are very basic. So I have to upgrade the slides. So it's nothing modification, it's upgradation of the slides. So that's why I have to add multi-factor authentication instead of authentication, authorization, and identification. So I just upgrade a small section. For security standard, so in our previous lectures, those we are using information security management system. Okay, so still those standard are obsolete and nobody's using that. So no point to discuss in any venue. So this lecture is a little bit upgraded. Okay, so standard. We have so many different standards. Okay, standard means it must be for everyone. Okay, like if we are using mobile devices, so there is a standard how to design mobile devices. Okay, so for the vendor there is a standard, for user perspective there is a standard. Okay, we cannot deviate from the standard. Like if I have a mobile device and then I need an ear on my mobile device. It's just joke. So if I need an ear, human ear on my mobile device, so none of the standard discuss about how to create an ear on the mobile devices. So it's standard means it's typically standard for everyone. Okay, so we have to follow those standards. Like we have IETF, Internet Engineering Task Force. This is one standard. Their job is to ensure internet engineering. Okay. Then we have European standard, ITU, International Telecommunication Union. All those 3G, 4G, 5G, 6G cellular network. all those things are under ITU. If we need to have anything about, we need to refer to cellular things, okay, we have to refer to their standard. Inside ITU, we have so many small different sections. IEEE, this is again one of the big organization. Okay, so they have their own standard, just like Wi-Fi. Okay, 802.11 Zigbee. I think you have most of your FIP projects are using an IoT. So those Zigbee is under IEEE 802.11, 802.16, 802.20. Those are all IEEE standard. So I'm the senior member for IEEE. Okay, so baseline, the minimum level of protection that should be considered by all organizations utilizing IT system. So this is our basic. Normally those standards, all the researchers, if I'm a researcher in cellular system, okay, this is my expertise 1 and 2. Okay, so I publish around 100 articles. If you see in my Google Scholar, both all those are in these two areas. Okay, so the standards are minimum level of protection. Then later on, the researchers, just like you are the emerging people, okay, so later on, if you need to continue your research work, you have to read those standards first. Okay, and then once we read, no need to go to their PDF version. If we read other articles, we can easily know what are the baseline security. Okay, so for this, let me see. Wait. Sorry, this is. Okay, sorry, I just opened the previous lecture. So this one is example ISO IEC 27001:2007 Information Security Management System. Okay, so this is one of the example. We have so many standards. Okay, so for information ISMS, okay, for this we have this standard. Okay, many organizations will require protection considerably above the baseline level. Okay, but baseline must be there. Okay, so okay, this both lecture are under literature review. So no need further explanation. Everything is there. I just take the lecture from, there's a reference from the Malaysian standard website. Okay, so this one from, you see, jsm.gov.my. So the reference is at the last slide. Okay, so I never change a single word. Okay, because this is a standard. It's a copyright stuff. So this is for sharing session only. Okay, so we have this very popular standard. Okay, ISO IEC 2071 Information Security. So this is the main broad standard. Okay, so inside this we have several further standards. Okay, when it comes to keeping information assets secure, organizations can rely on ISO, this family. Okay, so we have ISO IEC 27002 in 2013, information technology. So this was the first standard. Okay, not the first standard. This is one of the standards, so which was withdrawn. Okay, then we have another standard 016 previous and withdrawn. Then we have this latest version. Okay, instead of 16 there is upgradation, so we have 2018. Okay, so instead of this it's withdrawn, we have 2013. This is 27002. So this is 27001 2013. This is the latest version. And for this, the previous version 27001, 2005, it was a previous and withdrawn. Okay, so we have currently two different versions. This one and this one. What are the differences? This is more on, if we have some agreements, there is some vocabularies. So this one 2018 is more on vocabularies, definitions and vocabularies. This is requirements. Like Unimus, if we need to get this ISO, so what are the requirements we have to follow? So this is requirement base. If any of us design one company, okay, say any of my students, sir, this is my company and I need to get ISO standard. Okay, so if we have that standard, okay, so if we get the standard, so we are globally recognized. Okay, so how to get the standard? There is some requirement. So instead of having definitions and vocabularies, so requirements are one of the main ISO concern. So our concern for this lecture will be information technology. This one, 27001, 2013. Okay. The first one, this one is withdrawn. Okay. Information security technologies, code of practice for information, okay, security controls. It was designed to be used by organizations that intend to select controls within the process of implementing an information security management system based on this. One thing, implement commonly accepted information security controls, okay, develop their own information. So this is for a specific organization, okay, used by organizations that intend to, which means we already scope the organizations, not for every organization. So that is withdrawn. This one is for all organizations, okay, and it's an overview and vocabulary. Okay, so this is more on definitions, vocabularies. Okay, so and it can be for all organizations. Okay, so this is what is our concern for this lecture. This is 2013 information. Again, it's a information technology security techniques, information security management systems, and requirements. Okay, how to get ISO. Okay, so what is the scope of this standard? The scope of this standard is information security management system, ISMS. Any data, software, any data, okay, information security. So any information. So this Unimus have already this ISO, this because since I am the evaluator, I am the internal auditor. So last 2 years, because every 3 years we have to do this to ensure we comply with the policies and standard. Okay, so the scope of this standard is ISMS. Okay, there's nothing maybe not with the management, how to hire foreigners, there's some policies and standard. So how to enroll students, there's some policies. Okay, those are different things. So this is specifically for information security management system. Okay, so this is a little bit boring, okay, but I have to read those things, okay, because since I just took this from the Malaysian government website and I cannot change this. So but once I read it, it's a very simple and easy to read. Okay, what does certify to the standard means? So just like if Unimus is certified to ISO 27000, okay. So what does it mean? It means that an organization has established a systematic approach to protect specifically sensitive information from a wide range of threats, ensure business continuity, minimize business damage due to attacks, leakages and natural disasters, maximize return on investment and business opportunity, okay, it encapsulates people, processes, and information technology system. In the context of this standard, the term of information includes all form of data, documents, messages, communications, conversations, recordings, and photographs. So anything information, so this all include. So if we have successfully established systematic approach to protect, so which means that we can go for ISO. This who should apply? Any organization of any size. Okay, there is no scope for this. Any organization can apply for this. What is the certification cycle? Okay, so we apply. Okay, so then there is an audit. We will see it's appropriate or not, and then once we have audit, we see we comply with the compliance, just like we have 2 internal and 4 external auditors. Okay, so we see either the organizations complying with the standard. If they are complying, they have all those things. Okay, then we allow the certification. It means that this organization is certified for this ISO. So we have yearly monitoring, okay, and then after 3 years we have a reassessment. So this is the cycle. What are the benefits? Okay, this secure business continuity by protecting information, which has now become your business critical assets in terms of confidentiality, integrity, and availability. This is done by ensuring the right people, processes, procedures, and technologies are in place to protect information. If you see, this is all easy going. We have done that. Okay. By complying to the system, you are safeguarding your business. So these are all benefits. And providing your customer, supplier, stakeholders with confidence that you are aware and capable of managing information security risk, and implement educate control to mitigate or eliminate the risk. Example, CIMB Bank. If this is not ISO certified and I am the customer, so I'm reluctant. I say, okay, if something happens, if I'm the stakeholder, I'm the one of the investor, okay, so my confidence level will be minimal. Okay, so if I see if this organization is, if I'm an auditor, or we have to trust the auditors. Okay, we are very serious guys. Okay, once we go for auditing, it's a 7 days procedure. It's not 1 day or we just go and sign. No, we have to go, and there's a set of rules and regulations. Okay, so once we audit and we give the certification, which means that all have the confidence level of 99%. Your business will save more money for security incidents, as the cost of preventing security incidents will be lesser than cost of handling and correction. Okay, for sure. Okay, if we have ISO, then no need for handling those. Unimas, sometimes we receive denial of service attack. We receive so many traffics in the email. So there is a standard for that, how to deal with that. So we follow the standard and we handle basically with lesser cost. The system promotes continuity improvement. Okay, it's a continuous process. Okay, it's not like every time we cannot go from the scratch. Okay, so we learn from the previous things. If there is some attack or impersonation or anything, we learn from that. So improve. Next time we have another attack, but not those previous attacks, which will provide your business with the competitive edge to compete in the marketplace for those who have succeeded, to become more successful and resilient. The system also look into the needs of your human resource, which also increase staff morale, okay, and commitment in safeguarding critical business information. Okay. Comply to standard provide you with the rewards for competitive edge. Okay, all of the above will increase profit and business security. Yeah? So this is, if any, even for Unimas, if academia, but most of this we need with the industry where economy involved. Universities are non-profit organizations. Okay, so what we earn, we spend. Okay, we are not looking for profit, but those economy sector, those industries, they are role model for, they are participating in national economy, so they need to go for that. So these benefits are critically for them. Okay, so we have a different clause 4, 5, 6, 7, 8. One is ISMS requirements. Then we have management requirements. Then we have internal audits. Then we have management review. Then we have measurement, analysis, and improvement. Okay. Okay, so I will not go all those. So I will just give a very quick overview. Requirements. Establish information security management system based on process, approach, and implement and improve. Okay, so to do this, we have certain steps. Define and plan your system, analyze and evaluate your organization's risk, identify and evaluate risk, those 10 steps. Okay, select control objective and control to treat risk. Okay, then ensure that management approves the residual risk. Okay, obtain management approval. Okay, prepare a statement of applicability. Okay, SOA. So these are established information ISMS system based on. So first we have to establish the system. So once, if there's no system, how to get ISO certification? Okay, so first we have to establish the system. Okay, and then we have to implement and operate. Okay, so we haven't done our auditing. We haven't done our ISO application. First, we have our establishment of this ISMS. Okay, then we implement and operate. Now we have in Unimas, we have ELIP, we have single identity, we have all those things. So develop and implement risk treatment plan. Okay, implement your organization security control, implement training and awareness. Now we have ELIP, we have single ID. So we are training people. We are creating awareness about those softwares. Manage and operate your organizations. Okay, ISMS. Manage these resources, all those lecture slides, your results, whatsoever. Okay, establish procedures on identifying events and response to security incidents. So this is under implement and operate. Then once we have to monitor and review. Okay, implement monitoring and reviewing procedure. Okay, perform regular reviews. Normally from the lecturers, from the students, we get the feedback. Okay, review your risk assessments. Okay, conduct. Okay, now we have before we go for external audit, we have to go through rigorous internal audits. We go for each and every functions. Okay, so either to secure or each and every point. Then we conduct management reviews for your ISMS and update your information security plans. Maintain record of whatsoever we have done. We have to maintain the record. Okay, so monitor and review. Then we maintain and improve. Okay, you see, this is all sequential. First we establish, then we implement and operate, we monitor and review, get the feedbacks, and then we maintain and improve the system. Okay, implement identified improvement, perform suitable corrective and preventive actions, communicate action and improvement. Okay, so those are the maintain, and now just visualize ELIP, all those things are in working. We haven't. Okay, then we document your system. Okay, this is one of the critical things. If we don't document the system, we cannot apply for ISO. So we have to document the system and explain how it works in your organization, all your system sequence, all your software engineering diagrams, from manual procedures, work instructions, etc., and must include a statement of ISMS policies, procedures, and control requirement. So once we do the internal auditing, we get the book. So once we have all those books, 1-2 days, we just read those books and try to see, since this is the expert area of the internal auditor, so we read one by one, and then we try to see, is there any hole, okay, any loophole. Okay, so once there's nothing, we we go and check the system based on this book. Okay? So document your system is one of the mandatory requirement. Risk assessment report and risk treatment plan. Okay, so this is all your documentation. Document control procedure to control documents used for. Okay, so this another for this document. Record control procedures to control records that are used for ISMS. Okay. Okay, this is clause 5 management requirement. Okay, the management of your organization need to show evidence of commitment to the establishment. Okay, those things are for ISMS. Establishing an IM's policies, objective and plan. Okay, this is under management. Establishing roles and responsibilities. Okay, refer to our previous lectures. Communicating to the organization the importance of meeting information security objective. So we have to discuss. Provide sufficient resources to establish, implement, operate, monitor this system. Deciding the criteria for accepting risk and acceptable level of risk. Ensuring that internal ISMS audits are conducted as planned. This is one of the universal responsibility, any organization responsibility. Conducting management reviews. Okay. Identify resources needed for system. Okay. Ensure competency of human resource. Identify what training are required. So evaluate competency after training. Okay. So this is under management requirements. Clause 6. So once we have designed ISMS, okay, and then we have all those management, fulfill all those management requirements, then we go for internal auditor. Okay, ensuring that internal ISMS audits are conducted as planned. So this is around 6 to 7 very rigorous days. Okay, establish internal audit procedures and conduct audit as planned. So we have internal audit. Okay, and then once we see everything okay, then we have external audit. So once we have this to audit, then we apply for ISO. Normally we get that. Management reviews. Okay, we have to conduct management review meeting to evaluate the effectiveness of the system through assessing the review input and by ensuring the review output include the decisions and action required. Okay. Then measurement, analysis, and improvement. So based on all those previous steps, we have to measure, analyze, and improve our ISMS system. Ensure results of continual improvement. Okay, so once we measure, analyze, and improve, so every time, every 2 years, 3 years, or after internal audit, so we have to, continuous improvement must be there. So if there's nothing from the scratch. And the effectiveness of the ISMS through the use of policies, information system objective, audit results, analysis of monitoring. So based on all those things, we have to continuous improvement. Establish procedures on corrective and preventive actions. Okay, so this is all our. Okay, so this is very generic slides. We have security policies. If there's a new system, just like ISMS new system, we develop, we do risk analysis, we do all those recommendations, technical, physical, personal, procedural, legal, those things, and then we implement. Okay. Once we implement, we install the system, we monitor, maintain, train, and reassess. So normally this is all our whatsoever we discuss lecture 7 and previous slides. This is the nutshell. Okay, this is managing security. This monitor effectiveness of the technical measures. Okay, monitor compliance by staff. We have to see either now once we have everything, so the staff, the students, or whatsoever, they are following those the policies and standard. Maintain protection by acting upon monitor information when necessary. Okay, provide generic and specialist training. Okay. Product assessment, ensure that new systems are developed. So this is all basically reoccurrence of the slides and the same method. Okay, so this is a very old slide, but still good, valid. Basically, security is, I have in 2018, I was 17, I was the keynote speaker in one of the Chinese university in China. So I have to, they give me the topic that security, there's nothing, all the system is prone to some attack, unless until we go for blockchain, just like trustworthiness. So blockchain is one of the current era that can ensure a good security level. But if we talk about those Diffie-Hellman algorithm, Algama, your ECC, those are, if we have quantum computing, those are all null and void, easy for password guessing. Okay, so nowadays we have, in 3 months, we can guess a very easy passwords, and just like dictionary attacks, brute force attacks, and so we can get the passwords. So, but if we have quantum, we can get using those pieces in maybe 3 months. But if we have quantum computing, just like Google, they are planning to, so it's very easy within seconds and nanoseconds we can guess the password. So this, the game is the password. So that is, if we, in I think in our lecture 6 or lecture 5 or 4, and there is a slide, if we have password is secure, everything is secure. Means if the door is locked properly and if someone is knock at the door, we don't verify and open the door. It's our own scam. We scam with ourselves. Okay. So every system is not 100% secure unless until we have trustworthiness. So blockchain is more on trustworthiness rather than security. We use only hashing in blockchain. There's nothing, but recently I published one article. We are integrating blockchain with those top tier crypto system. So just to make sure the system is secure. Okay, must determine the appropriate level of countermeasures. Okay, require a mean to address the problems in the consistent and structured manner. Baseline security helps, but it's not a total solution. Okay, so that this lecture slide is adapted from the official website of Department of Standard Malaysia. This is our government website. So, okay, maybe later I will put the link here. I think I forget the link here. So if anybody can refer, I need to refer to in future, maybe, because now we are in the learning phase. But once we complete our graduation, so we are in implementing phase. So if anybody plan to join any organizations, so they are at the initial level for ISO, just refer to the slides. I have tried my best to address all those things relevant to get ISO. Okay, for this, thank you so much. Okay, thank you so much. Thank you so much. So next Friday, we'll have only attendance. So later I'll announce in WhatsApp and e-lip. Okay, take care. Bye-bye.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.